Hello, welcome to our CAOS video project. In this video, we will be talking about basic input and output. The topics we will touch on are assessing input-output devices, program control input-output, interrupts, bus structure, bus operation, and interconnection standards. Basic I/O stands for basic input and output. A few examples of input devices are keyboard, mouse, microphone. A few examples of output devices are speaker, printer, monitor. An example of both input and output devices are headset and touchscreen. Assessing I/O devices. Locations associated with I/O devices are accessed with load and store instructions. Example, if data in is the address of a register in an input device, load R2 data in, reads the data from data in register and loads them into processor register R2. Example, if data out is the address of a register in an output device, store R2. Data out sends the contents of register R2 to location data out register.
Program control I/O reads keyboard character stores in memory and displays on screen. Implement tasks with programs that perform all of the relevant functions. Keyboard circuit places the ASCII encoded character into the KBT data register. At the same time, the circuit sets the KIN flags to 1. Meanwhile, the processor is executing the I/O program which continuously checks the state of the KIN flag. When it detects that KIN is set to 1, it transfers the content of KBT data into the processor register. Once the content of KBT data are read, KIN must be cleared to 0. Second character is entered. KIN sets back to 1. The process repeats. Program control I/O requires continuous involvement of the processor in the I/O activities. Wasting processor execution times in this manner can be avoided by using the concept of interrupts. Programs enter a wait loop in which it repeatedly tests the device data. During this period, the processor is not performing any useful combination. While waiting for I/O to be ready, processor can perform other tasks to allow this to happen. We can arrange for I/O device to alert the processor when it's ready. It can do so by sending a hardware signal called interrupt request to the processor.
Bus structure. To transfer data among the processor, memory, and I/O devices, an interconnection network is used. The bus consists of 3 sets of lines to carry address, data, and control signals. Connected to these lines are I/O device interfaces. Each I/O device is assigned a unique set of addresses for the registers in its interface circuits. Bus protocol, which is a set of rules governs how the bus is used by various devices. The bus protocol decides when a device may place information and may load the data on the bus into one of its registers. These rules are executed by control signals that specify what and when actions are to be taken. Bus operations. In any data transfer operation, one device plays the role of a master. The device addressed by the master is referred to as the slave. 2 approaches to timing of bus transfer: synchronous, asynchronous. Synchronous bus. All devices derive timing information from a control line called the bus clock. A clock cycle or bus cycle defines a time slot. At the beginning of a clock cycle, all the events start. Asynchronous bus. An alternative scheme for controlling data transfers on a bus is based on the use of a handshake protocol between master and slave. A handshake is an exchange of command and response signals between the master and the slave. Data transfer is controlled by 2 interlock signals, master ready and slave ready. Whenever the processor takes an action, it waits for the device interface to respond before taking the next action, and vice versa.
Created using PowToon.
Interconnection standards. Standard interfaces have been developed to enable I/O devices to use interfaces that are independent of any particular processor. USB. USB is the most widely used interconnection standard. A large variety of devices are available with a USB connector, including mouse, disk drive, printers, cameras, and many more. There are several versions with speeds up to 5 gigabits per second, with the original USB with minimum up to 1.5 megabit per second to 12 megabit per second, USB 2 to 480 megabit per second, and USB 3 up to 5 gigabit per second. USB provides a simple, low-cost, and easy-to-use interconnection system. It accommodates a wide range of I/O devices and bitrate, including internet connection, audio and video application, enhance user convenience through a plug-and-play mode of operation. PCI bus was developed as a low-cost processor-independent bus, used most often on the motherboard of a computer to connect I/O interfaces for a wide variety of devices. Interface circuit. The I/O interface of a device consists of the circuitry needed to connect that device to the bus. On one side of the interface are the bus lines for the address, data, and control. On the other side are the connections needed to transfer the data between the interface and the I/O device. This side is called a port. A port can be either a parallel or a serial port. Thank you for your attention. We hope that you enjoy our video, Masters of Chaos.
Created using PowToon.